This lesson, we analyze the parallel RC circuit. First, we're going to review the formulas, and then we have one example. The best way to improve the skill for solving the problems is to do lots of exercises. So first, let's review the formulas, important formulas used to solve this kind of questions. We have the Ohm's law formulas. V equal I, the current, times the impedance Z. Current is the voltage divided by impedance, and the impedance can be calculated by voltage divided by current. Now we have the power formula. Power formula P equals to V times I. Power also can be calculated by current squared times impedance. Power can be calculated by voltage squared divided by impedance. Here we have other formulas that we might need to use to solve the RC parallel circuits. The first one is the capacitive reactance formula. Xc equals to 1 over 2 pi frequency times the capacitance. And then G equals to 1 over R. G is the conductance. It is defined as the reciprocal of resistance. Bc, that's the capacitive susceptance, equals to the reciprocal of capacitive reactance. The admittance is the overall conductance and also the capacitive susceptance. So it is the square root G squared plus Bc squared. Impedance, it is square root R squared plus Xc squared, which is the inverse of admittance. The phase angle theta is the inverse tangent R over Xc. This is for RC parallel circuit. Now let's solve one problem. Use figure 1, we need to determine the conductance of the resistor R, capacitive susceptance of C, and then the total admittance. After that, we need to find the current in the main branch, which is the current here, and then the phase angle. So given the resistance R equals to 1.0 k omega. From here, we can find the conductance G. G, it is the inverse of resistance, so it is 1 over R. R is 1.0 k ohm, so here is 1. If you remember, the unit for conductance is Siemens, so this is 1 millisiemens. Next, we can find the capacitive reactance. And this is Xc. Xc is 1 over 2 pi Fc. Plug in the numbers, it is 2 pi, so 2 kilohertz is the signal's frequency, times capacitance 0.02 microfarad. And this is 2 pi. 2 kilohertz is 2 times 10 to the power 3 hertz, converted to the standard unit. And then microfarad, 0.02 microfarad, it is times 10 to the power negative 6 farad. Use calculator and then find that this equals to 3.98 kilo omega. Since capacitive susceptance BC is 1 over XC. And here is 1 over 3.98 kilo omega. Use calculator, I got 0.251 millisiemens. Now we can find the total admittance. That is Y total equals to square root conductance squared, G squared, plus capacitive susceptance squared, that is BC squared. Plug in numbers. G is 1 millisiemens square plus BC it is here 0.251 millisiemens square. Use calculator, I got 1.03 millisiemens. We find everything for part A, and now let's work on part B. Part B, we need to find the current first. To find the current I total, we can either use the Ohm's law, V over impedance. But we haven't found the impedance yet. We can find the impedance using this formula. We know impedance equals to the reciprocal of admittance. How about let's use the admittance directly? We know I total can be found using the total voltage times admittance. This is another formula to find the current. We know the source voltage is 5 volt. And then the total admittance we calculated, it is 1.03 millisiemens. Enter these numbers in the calculator, we got 5.16 milliampere. And then we can find the phase angle. And the phase angle is theta. Theta is inverse tangent. For parallel RC circuit, the numerator is resistance, and the denominator is capacitive reactance, XC. This equals to inverse tangent. Resistance is 1.0 k ohm, and then the capacitive reactance is 3.98 kilo ohm. Use calculator, I got 14.1 degree.